Everybody, we are moving on. We are now in section 2, unit 2, section 3. We're dealing with intercepts of graphs, and this is a really important thing to wrap our minds around in any math class from here forward. We have intercepts. We have x-intercepts. We have y-intercepts, and they're exactly what they say they are. It says x-intercepts are where the graph crosses the x-axis. You want to think of this in terms of like an ordered pair, right? It's when your y is 0. So think about that. Like if you're on the x-axis and you track that, you go to the y-axis, the value of y right there is 0. In turn, reverse it. We're looking at the y-intercepts. Well, this is where the graph crosses the y-axis. And in that case, where that y-axis is, the y-axis crosses the graph, the x-coordinate is 0. So you always want to think about it like an ordered pair, because a lot of times they will ask us to write the x and y intercept as an ordered pair. And we have to make sure that we do this correctly. Again, our first two examples, they're really pretty easy. If we were to be asked to identify the x and the y intercepts, you look at your line. This is here. It's a linear equation because it makes a line, right? And right here, you can see is your x-intercept because that's where that line crosses the x-axis. Right here, look, that is your y-intercept. That's where the line crosses the y-axis. And if you needed to write your coordinates, remember, when we do ordered pairs, we're always making sure that we are doing your x-coordinate first, or your left or right movement comes first, then your up or down movement. Notice an x-intercept, we went over to the left 2, so that's -2. And you're not going up or down, so your y value is 0. Again, it's a great way to identify these when you're looking at maybe tables of values or something. You're looking for zeros that appear in your table of values. When you see that the y value is 0, you know you have an x-intercept. This one over here, look, if we were to write this one, well, we start out at the origin, right? We don't have to move left to right, so our x's are 0. We have to go up 3 units. So that's the ordered pairs. Notice sometimes, depending on the shapes of our graphs determine a lot. We can have more than one x-intercept. This graph, which you will eventually learn is quadratic, but this is right now, all we know is a non-linear graph because obviously that is not a straight line. Has 2 x-intercepts. And then you can also see in it, the y-intercept is right here at 12. And again, if you want to write your ordered pairs, you'd be very careful when you do so. I just have right here, we go to the left first, left 3, so it's -3, comma 0. This one here would be, oh, look, this one fooled me. We always have to be careful. See, if it fools your teacher, it can fool everybody. Notice what they did to us. They were sneaky. They changed our margin in the graphs. We're not going by ones. Look, 2, 4, 6, 8. So that's the assumption that all the lines on your x-axis is represented by a 2. So be careful. Remember, we must be careful. So again, if we're going to fix this one, right, it's 2, 4, 6, -6, 0. We look at this one over here, 2, 4. So this is the point 4, comma 0. And look, even the y-axis is getting sneaky. They went by 3s. 3, 6, 9, 12. So this coordinate here would be, look, from the origin, we didn't go left to right. The x is 0. And then we went up 12. Right there. That's how we can identify our x and y intercepts from a graph. Very, very easy. Can be difficult, though, if they change the margin and they, like this one is assumed to be 1. This one here, they gave us numbers. So then we have to look at it and make sure we're picking that right interval, all right? Another thing that we have to look at with graphs sometimes is it's this term where they say the graph is positive or negative. So in math, positive and negative has slightly different meaning than like in the real world, okay? It's not just being nice or you're being mean. Positive means that your solutions to the equation are positive. And when we say negative, it means your solutions to your equation is negative. And when we put them on a graph, it does something special. It means when all of your outputs are positive, the graph is going to be above the x-axis from wherever that x-intercept is of that graph. Everything that's above the x-axis is considered positive. Everything below the x-intercept is considered negative. So again, negative is when your outputs have a negative result. And when you graph them, you'll notice those points are either above the x-axis or the below the x-axis. And when you connect the line, you're able to use your x-intercept as like a point of reference for this. Let's see how it works when we actually look at a graph. Okay. So here is a nonlinear graph. We can see that because obviously this graph does not look like a line, right? It's not that it is the shape of the graph is important. It's really just looking at, so let's identify where are those x-intercepts. I have an x-intercept here. I have an x-intercept here. Right? So if I'm looking for the positive points of this graph, look, the positive is this section right in here. It's all these points that are above the x-axis that are now unshaded, right? So look at your x-axis. From what values of x is this graph above? And I can see it's an in-between state, right? All the numbers in between -2 and +2, when you plug that number into the equation, whatever it might be, and you evaluate it, you end up with a positive result. So the coordinates that are plotted are all sitting above your x-axis. Okay, so if we want to go ahead and write this, we use inequality notation. Right? Compound inequality to be more specific, because we studied that in our unit 5. We go what? Be careful. We're dealing with a number line here, so you need to go to the far left spot first, because this is the number that would come first on a number line. That's -2. And in inequalities, we always use less than. Our variable is an x, because that's what's dealing with the domain. Domain deals with x's. And then it comes all the way up here to, boom, +2. So for when our x values are in between, this is how we read this. When our x values are in between -2 and +2, our graph is considered to be positive, or even more specific, all of the outputs. When you input any number between -2 and +2, the outputs are positive. And that's how we get this above here. If you want to look at the negative side, well, now we're dealing with a number line like we did in unit 2. There's 2 sections of the graph in this one that could produce negative results. So again, you start at that y-intercept. So any number that is less than on this side here, right? Because if we go over here, we have to go down to the graph. We got to this number, we have to go down to the graph out here. Any number that's less than -2, or any number that's greater than +2 will give you a negative output. And that's how we are determining whether a graph is positive or negative. We're looking at what are we putting in and what is our result. The result's negative, well, then that portion of the graph is in the negative area. And we can look at it simply by looking at the graph, and we use those key points, the x-intercepts, to help us determine that. Here's another graph here. We're looking for positives and negatives. This time, if we identify these key points, here's our x-intercept, right? I notice that the graph is above the x-axis only for x values that are less than this intercept. That intercept is what? 0. So for right there, any number that's less than 0 causes the graph to end up having a positive output. So here we go. Look right in here. Anything from here to here is going to be positive. Anything from here to here is going to be positive. And how do we get these? Well, as you keep plugging numbers in, any number greater than that, you start getting it. So look, what is this? So x is less than 0. It goes in that direction. And when you have x that's are greater than 3, all of those outputs are then on the positive side. If you want to do the negatives, again, look, negatives are in this whole different ball. They're over here. So our negatives are falling in between that key point, those x-intercepts. So it's in between the values of 0 and 3. Any number we plug in between these two numbers is going to give us a negative output, and therefore your graph is negative in those positions. It's really about identifying those x-intercepts and then figuring, you look to the left of it, is the graph above or below? You look to the right of it, it's above or below. Sometimes graphs have these symmetrical style graphs have two different directions, so we can have multiple positive areas, can have one negative area. Here we had multiple negative areas, one positive area, and we represent them using our compound inequalities. Easier ones are here, like when we have a line, right? You want to know when is the graph positive, you look at your line. Right here is our intercept at 2, and anytime we plug in a number greater than 2, we're going to have it be positive. And anytime x is greater than 2, it's positive down here when it's negative. Anytime x is less than 2, the graph is negative. Right? So think about that. So there's another way that we're using x-intercepts to help us describe these key features that we see inside of these graphs. Another interesting thing is like, well, how do you find x and y intercepts if the only thing they give you is an equation? Again, it's just like what we said before. We want to make sure, like when we're trying to find this x-intercept, we know our value of y is a 0. So if they give you an equation, you use the law of substitution. Well, what do we substitute? If you want an x-intercept, you need to plug in a 0 for y. And if they ask us to do a y-intercept, we need to plug in a 0 for x. And you can easily do this with a few of our problems here, right? Take a look at this one. If we want to plug in the easiest one is the y-intercepts. I think these are always the easiest to find, right? So I like to do this one first. I need to plug in a 0 for x and evaluate it. Watch, if I plug in a 0 here for x, 0 times 3 is 0. And 0 plus 4 is 4. So when my x is 0, my y is evaluated, you get a 4. That's your y-intercept, or your y-intercept. Easy. Also, notice that's slope-intercept form. Y equals mx plus b. Your slope, y-intercept. That's why we like that form. It gives us an answer. Look at the next one. If we're going to do the x-intercept, this is the one that we have to do more work. We actually have to take this y here, and we are going to substitute this y for a 0. 0 equals 3x plus 4. Now you just solve. We're just solving the equation for x to find our x coordinate, right? And we know that in the end, our result, we plugged a 0 in for y, so we know our y is 0. We're trying to reverse engineer this. We subtract 4. Cancel. Then we divide by 3. These cancel. So now you know your x is equal to negative 4 over 3. That's your y, or your x-intercept. And guys, this is important. Like, a lot of times on graphs, our intercepts don't fall at the nice, pretty numbers that we see on a graph. So when it doesn't, our only option to find them is to manually calculate them like this. Negative 4 over 3, you don't see that on a graph. It's somewhere in between two numbers. So in order to get it exact, you have to manually calculate it. You guys go ahead and you pause the video and you try to do it for this one. Remember, this one's in a standard form, not a slope-intercept form. So you're going to have to actually work them out both times. Pause it and you try. All right. We'll go ahead and solve these. Let's do our x-intercept first. So for an x-intercept, again, I'm going back to my directions I have. that are in my notes. This is what you should do when you're doing your homework. It says for an x-intercept, plug a 0 in for y. So I'm going to write this equation once. I'm going to plug a 0 in for y. I know this whole thing turns to 0. 0 times 4 is 0. All right, that just kind of goes away. I'm left with 2x equals 14. I can divide by 2. X equals 7. All right, so when my y was 0, my x was 7. There is my x-intercept. Great. Now we got to do the reverse. Back to our directions. When we look here, right, when to find our y-intercept, we plug in a 0 for x. So I'm going to do that. Plug 0 in here for x. Well, that turns that to a 0. Plus 4y equals 14. I can't do anything. Don't even have to worry about that. I can divide by 4 to get my y by itself. Now notice, please be careful. Do not put your answer as a decimal unless the problem tells you to. In this case, we have 14 divided by 4. We can reduce this. They're both divisible by 2 is their common multiple here. Divide both pieces by 2. So you have 7 over 2. So in this case, y-intercept, which means when the value of x is 0, what is the y? Is 7 over 2. And again, that is one it's not on a pretty number on the number line. The only way you can get this is by actually evaluating the equation. How do we do that? Right here. Guys, I'm telling you, this is a key concept. It is used in every math class going forward. When you need to find an x-intercept, you need to know you're looking for when is your y 0. When you're looking for your y-intercept, you need to know when is your x 0. You got to be able to plug it in and find them. So this is very, very key concept. Flashcard it, put it on your notes, get this into your long-term memory. Think about it every day, all right? Last one we're going to look at here is tables, okay? Obviously, if we were to sit here and evaluate bunches of values for x and put it onto a table, that's what a table tells us. Here's all of my inputs and here's the outputs that go with it. So when they have a table, it's one of the easiest ways to be able to identify our x and our y-intercepts. We want to know our y-intercept. When is our x 0? You look at your table of values, and if you see a 0 in it, right there, voila, you know that that is your y-intercept. Here we go again, right? You're going to look at this, and if you see a 0 in your y category, like right here, you know right away that is your x-intercept. And if you don't believe it, you can graph this graph, right? Make a quick sketch, and you'll notice that whatever the shape of this line is, you drop all the points on the line, connect the line, all the points with a line, and you'll notice that they touch at the x-intercept right here at 1, and on the y-axis, it'll cross at 9, and then you're able to find your x and your y-intercepts. We can use this information for all kinds of things and be able to determine that, oh, these initial values, the y-intercept has meaning when they give it words, the x-intercept has meaning when they start to give it words. And that's some of the things that we'll look at in our homework, right? So get out there, get your homework done, guys, and have a great day.